All right, section 3.11, hyperbolic functions. Not one of the most important things that we do in Calc 3. However, it is very important in real-life applications. And you're going to have a chance to see that at the end. My goal is to keep this video under 20 minutes because the last couple videos that you guys had to watch for conic sections were a little long. So again, I apologize. The homework, once again, this will be something that we talk about in class. Very short on this one because, again, not one of the more important things that we do overall in Calc 3, but it is important to talk about at least a little bit. So what the heck is a hyperbolic function? Well, we'll talk about that as we go, but most frequently we use hyperbolic sine and hyperbolic cosine functions, hyperbolic secant functions as well, but in basic calculus mathematics we don't typically use secant too often. All the other hyperbolic trig functions can be found as well: cotangent, tangent, cosecant. We're just not going to do a whole heck of a lot with them. So what we're going to do is we're going to define specifically hyperbolic sine and hyperbolic cosine first, and then we'll talk a little bit about the other one. So hyperbolic sine, it's S-I-N-H and then x. X is the angle. The H stands for hyperbolic. Depending on what college and everything you go to, some professors might pronounce this cinch. It's really bad, I know, but that's the way they pronounce it, is cinch. Anyway, it's defined to be, hyperbolic sine of x is defined to be e to the x minus e to the negative x divided by 2. Hyperbolic cosine, pronounced cosh, cosh of x, is e to the x plus e to the negative x over 2. You can see that they're almost exactly the same. Hyperbolic sine is minus, hyperbolic cosine is plus. In the easiest form, instead of trying to figure out all these things with their e's and all that kind of stuff, tangent or tanh hyperbolic of x is still sine over cosine. So it's sinh over cosh of x. Cosecant is still the reciprocal of sine, secant is still the reciprocal of cosine, and cotangent is still the reciprocal of tangent. I don't know how you pronounce cosecant h of x. Cosech of x? I don't know. I'm actually guessing because we don't hardly ever use it. A lot of people do pronounce this one sech, which is 1 over cosh x, and I guess coth x. Again, I don't use it, so I'm not really sure. Some of your common hyperbolic identities are very similar to the regular trig identities, a few small differences. So if you were to take the sinh of negative x, it's the same thing as the negative sinh of x. What does that mean? Well, if I take a negative x value and I replace it with a positive x value, it changes the y value. What that means is that is an odd function. It is symmetric to the origin. Okay, no different than sine. If I take cosh of negative x and I change its x value to be positive x, it doesn't change the outside's y value. So that makes this an even function, very much like cosine. One of the changes is that you can see that you've got cosh squared minus sinh squared equals 1. Normally the Pythagorean identity is cosine squared plus sine squared equals 1. Well, this is a subtraction. There's a star next to that one because it's one of the differences. The Pythagorean identity is close, but it's not exactly the same in hyperbolics. 1 minus tanh squared equals sech squared. Again, slightly different than the regular one. You have your sum and your difference identities. The sine one is exactly the same as the regular sine of multiple angles added together. The cosh is a little bit different because it's also plus. In the regular one, it's the opposite sign. So just some identities you can have there. Not like we're going to do too much with that. So what we do want to do, however, is we want to take the definition that we used before for cosh and sinh, and we're going to prove that identity that cosh squared minus sinh squared equals 1. So what we're going to do is we're going to replace cosh squared with its identity, e to the x plus e to the negative x over 2 squared minus sinh, remember, is e to the x minus e to the negative x over 2. And we're going to show that when we go ahead and FOIL all this stuff out and work it out, it all equals 1. So, FOILing the top, let's see. E to the x times e to the x is e to the 2x. Multiplying e to the x times e to the negative x, you add the exponents with a common base, so that's really going to be e to the 0, which is 1, but you have 2 of those. So we'll double that and get 2. If you're not following this, go ahead and write it out. It's okay if you have to do that. And then multiplying e to the negative x times e to the negative x is e to the negative 2x. And all that is over 4 when we square the bottom. Okay, very similar thing on top of the right one. E to the 2x. This time it'll be a minus 2. And then plus e to the negative 2x over 4 equals 1. Good thing is we have a common denominator, so we can combine these tops. So let's see what we're going to have here. E to the 2x minus e to the 2x. Goodbye. E to the negative 2x minus e to the negative 2x. Gone. So now I have 2 minus a minus 2. 2 minus minus 2, of course, is 4. 4 over 4 equals 1. We're good. We've proved it. All right, if we were going to do some calculus here, obviously some of the things that would be important is we need to know how to take derivatives. So we're just going to write these down. I don't think that they'll come back into play with anything that we're really doing, but we're going to write them down just in case. So, just like in regular trig, the derivative of sine is cosine. In this case, it would be cosh x. One difference is that the derivative of cosh here is not negative sinh, it's just sinh x. The derivative of tangent in regular trig was secant squared. It's still secant squared. Oops, sec squared, excuse me, of x. Cosec of x, the derivative is negative cosec x coth x. The derivative of secant, while that was actually positive secant x tangent x, it is now going to be negative sec x tanth x. And then the derivative of coth x, while cotangent was negative cosecant squared, it's still negative, so it's negative cosec squared x. So really the only ones that were different, whoops, there we go again, I'm going to star them on the other side because it's not working over there. This one's different, and this one's different. And really it's just a sign difference there. Otherwise it's really the same thing as it is with the regular trig functions. Alright, all the differentiation rules that we use can be combined with chain rules as well, so it's going to be pretty much the same idea as if it was in Calc 1. The derivative of cosh of square root of x chain rule, you take the derivative of the cosine part first, which is going to be sinh square root of x multiplied by the derivative of square root of x, which is 1/2 x to the negative 1/2. So just kind of simplifying the way that looks, that's going to be sinh square root of x over 2 root x. All right. As far as that's concerned, I don't really think there's any need to go through too much more of that. Um, the more interesting thing is, where is this stuff actually used in real life? And it's actually used quite a bit in engineering and architecture and design. There are a few other things which occur naturally that it's also used for. That's going to be left up to you. Um, so you can see you should have a hyperlink if you're doing this on the computer. If not, you're going to have to type in that YouTube address right there. But the hyperlink should work if you're doing this on the computer. It should take you right to a video where somebody has already given us some of the real life uses. So your job is to write down at least 3 of them. If you want to go back in the video, you can actually watch further back, I believe, if you click on the YouTube video itself, and there are other things, but I want you to write down at least 3. And as far as that's concerned, that's all for this video. So we kept this one to a little over 11 minutes. That's awesome. All right.